Hi folks, welcome back to the lab in Holroyd 255, our physics lab. That's our systems lab as well. We do physics here, we do electronics here, we do materials here, all kinds of fun stuff. But today we're going to take a look at Module 2A, the integration of force, motion, and work. Okay, so I'm pretty sure I'll probably be talking about this in the actual PDF version of this, but for now, here we go. What we're trying to do is we're trying to see how all of these things are connected. I just named them force, motion, and work. And of course, the way we've described these things is that our motion equation under constant acceleration is our position equals x0 plus v0t plus 1/2 at squared. We don't need to memorize that because we always have access to this equation. And we've been playing with this cart for a while. We've been playing with this cart. We've added a force sensor on the cart, and it's been on this rail, and the rail has the positions on it. So this is our x-axis, as we've known before. Just a little review. Now it's down here is 0, and all the way up here, I believe, is 2.27 meters, or 2.20 right there, 220 centimeters. Fantastic. Again, we're also measuring force. We have our equation that the sum of the forces equals the mass times the acceleration of that individual item. The mass of the mass we're talking about is, of course, our little machine here, as we saw before. It also has to do with the mass hanging off the end of the pulley over there. And then this time around, we're also adding a new equation to this lab. Same setup, new equation, and that is work. And we've been talking about this for a little bit. Work equals the force that's pulling on this sensor. Here's the force sensor, multiplied by the change in position, which is this guy. So yeah, we can measure position, we can measure velocity, we can measure acceleration, we can also measure force, and we can also measure change in position, which of course gives us work. So work is just another way to describe what we're seeing. So we're not changing that too terribly much what actually we're measuring. We're not really changing the experiment. What we're changing is how we interpret the experiment. And that's pretty much the story of physics. As our understanding of physics and as our understanding of science gets more deeper, I shouldn't say more deeper, it gets deeper, then even though we're looking at the same thing, or at least it appears to be the same thing, we have a deeper understanding of what's going on. Okay, so let me turn a page here. Here's our procedure. It looks exactly like the other ones. We're going to take this cart with the force sensor attached to it, and here's the force sensor that senses things over here. We're going to use the string, which is attached to the mass holder. The mass holder, as you can see here, is 5 grams. And then we're on that 5-gram mass holder, we're going to put some different weights. And I believe those weights are 20, another 20, and a 50. I could be wrong, but if they are, I have a whole supply of weights here. We'll figure these things out. And we're going to let that thing drop down here to the floor. And again, we're going to use a pulley, which is going to redirect the force of this string. While there's a mass on the end of this string, the force is straight down, and then when we drape it over a pulley, all that does is, well, not all that, it's a pretty cool invention. What it's going to do is it's going to take the down force, or the tension in the string, if you will, or tension in the twine, that is in the y direction, and it's going to convert it into x direction, because all of our motion that we're really worried about today when it comes to the cart and its payload is in the x direction. So here, let's see what we got. So let's just work through this. I probably need my pen. I got my pen thing happening. Fantastic. Attach the motion sensor to the 0 meters at the 2.2 we have. Here's our motion sensor. Make sure it's sort of centered here. It's on the narrow beam, which we want. It's plugged in. Fantastic. Attach the super pulley to the opposite end of the track system. This is called the super pulley. It's very super. Mount the force sensor on the collision cart with the integrated screws. Here's screw number 1. Screw number 2. It is on the pulley, on the cart. It's ready to roll. Attach a length of twine. Already been done. Drape the twine over the groove of the pulley. Fantastic. Plug the leads from the motion sensor into the Pasco interface. The gold one or the yellow one goes into digital channel 1. The black one goes into digital channel 2. Also plug the force sensor into analog channel A over here, which is A. I saw it says I have 1 here in my screen, but it's the first one, A, B, C, 1, 2, 3. Double click on Data Studio icon and on the Windows and open the application. Here we go. So Data Studio. We're going to go ahead and open this guy up. New software. Hooray. I'm going to close that for now. We'll do that a little bit later. Data Studio. And we're in. Let's see if this guy works. And we're up. Wonderful. Close the startup dialog box. Okay, I shall. All right. And we want to change the interface and make sure it is on the Workshop 500 interface, which is what we've done before. So we're going to go here, go to Experiment, change interface, and we're going to go to 500, and we're going to say OK, and it should, it's looking, it's found, it's initializing, and we are good to go. 3, 2, 1, penguins. Fantastic, we're there. The interface is ready to use. There we go. Fantastic. The software should indicate that it has found the Science Workshop 500 interface. If this is not the case, please consult your instructor. Thankfully, we're good. The software should now be in experimental setup mode. There should be a window with a picture of the Pasco Model 500. It sure is. Press the Add Sensor or Instrument button from the analog. Add Sensor or Instrument. And from the analog, add the force sensor. There we go. So force sensor, there it is. Force sensor. There's 2 different versions. There's force sensor, and then they have a different version called force sensor student. Obviously, we're all students here. That just means it is a different machine. We want the force sensor. We did that, and the force sensor will automatically get plugged into connection A. I called it connection 1 by mistake. Here we go. The software should automatically place a picture of the force sensor, and we're good to go. Add a second one. Okay, add a force sensor or instrument. We're in. This time around, add a digital one. So Science Workshop Analog is the wrong menu. Pull this guy down. Science Workshop Digital, we're taken care of. And we want to add the motion sensor. There it is. And we're good. And we're saying OK. And motion sensor. And you can see there's a little tiny plug here. The yellow one goes to channel 1, digital channel 1. The black one goes to digital channel 2. And that's exactly what we have over there. Fantastic. All right, the software should automatically. The motion sensor will not be used in its default configuration, so we'll need to modify the configuration. Let's do that. Gonna put this guy back over here. Fabulous. Click on the icon of the motion sensor to select it. Right now, the force sensor is selected. There it is. Wonderful. You should click the motion sensor tabs. There's a measurements tab and a motion sensor tab. We do that. And we should do clicking. And it is clicking. Not only is it clicking, we can see the green light as well. It's doing this thing of a rate of around 2 times per second. Yep. 1, 2, 1, 2. That's close enough. Move the side of the collision cart that is closest to motion sensor to the position of 1 meter on the track. So look at that. It's almost already there. I must have been playing with it. So there's 1 right there. Cool. It's just sitting there at 1 o'clock. And we want to go ahead and make sure we set. So right now, it's at the standard distance is 1 meter. It's reading 1.014. If I press this button, it will readjust itself so that it's now at 1 meter. If I go look ahead and check, yep, it's at 1 meter. So it seems to be working pretty well. Wonderful. Verify that it works for the entire length of the track. So I'm going to go ahead and pull this guy down here. So when it comes down here, it's going to be around 203. I want to make sure that that's reading around, well, the magnet pushed it back. It's at 199 right now. And yeah, 197, 199, it's fine. It's going to be, it's not perfectly linear because it's not a perfect machine, but it's close enough. Wonderful. Change the sample rate to 20 hertz. Right now it's at 10 hertz. We want to change this to 20 hertz. Now that's not 20 hertz now, that's 20 hertz in the future. So we're still doing the click, 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 click. And we're good. So now that you have calibrated and configured the motion sensor and the force sensor, the experiment will be configured to automatically start and stop collecting data based on the position of the cart rather than attempting to press the start and stop button at the appropriate time manually. Okay, so here's what we're going to do. This measurement is like we did before. We're going to drape the mass over the pulley. The pulley is going to accelerate our cart with the sensor on top of it. And our goal this time is to do what we did before, but at the same time, simultaneously, measure the amount of force versus distance and calculate the work. So what we want to do is we want to start it back here, whatever this length is. I don't know where that is. It's sort of about here is where it's going to be at the top of the pulley. And then what we want to do is we want this thing to start moving. So what we're going to do is rather than wait for it 3, 2, 1, go, and then maybe I'm hanging around for a while, maybe it's not really moving. We're going to allow it to move 5 centimeters first and then start recording the data. And then before it crashes, before it actually hits this little guy down here, and before it hits the floor, we want it to stop measuring 5 centimeters before that happens. So we only want to measure a change in X between this stop position and this start position, whatever that happens to be. So that's how we're going to do that. So what I'm going to do is I'm going to grab this. This is just a measurement. We're not actually doing the experiment. I'm going to plug in or drape around my little tiny cart here. I'm going to bring this all the way back. Make sure what happens when this swings really wildly, it wants to fall off the track. So that guy is, that's as high as we will want to go. And what I want to do is I want to read what the lowest position of that cart is just on the thing. So I see that we're going to start at 95. So 95 is the lowest position of the cart, and that's in meters, so it's 0.95. It says here, please add 5 centimeters. Okay, so it will start at 1.00 meters. That's that plus 5 centimeters is 1.0. So what's going to happen is when I let this go, I don't have any much weight on that. It's going to start, it's too light right now, but it'll start moving. And then once it starts moving, as soon as it crosses the 100 centimeters start line, it will start recording. And then carefully move it to the end. I'm going to grab this guy over here. Wonderful. The whole way down here at the bottom. The end is where it just hits the floor, right there. So what I want to do is I want to find that position, and it seems to be 185. So the highest position of the cart is 1.85 meters. And please subtract 5 from that. Boy, these numbers are nice. 180. So 1.80 meters is where it's going to stop. So it's going to record from 1 meter to 1.8 meters. I'm pretty sure that delta X is going to be 0.8 meters or 80 centimeters. But we know that, but the software doesn't know that yet, but it's going to measure it for us, okay? All right. So now that we've done that, press the Sampling Options tab on the Equipment Setup dialog box. So, okay. Over here, we have Add Sensor Instrument, Set up Timers, Calibrate Sensors, and Sample Options. There we go. And let's see here. Under Delay Start tab, press the Data Measurement. So go to Delay Start. And rather than delaying it a certain number of moments, we're going to delay it based on a force measurement. And we don't want to base it on how strong it is pulling. We want to base it on the position. And we want to start moving or start measuring it after the position is above, in meters, 1 meter. So 1 meter. There we go. Nice. That's cool. And again, 1.0. I guess we'll put 1.0 in there because it really is 1.0. Fabulous. And then go to the delay start is above. We did that. And then configure the automatic stop. So automatic stop is right next door. Again, with a data measurement and not force, but position. And we want to see if it's above 1.8. We just measured that guy, 1.8. Great. And say OK. All right, so it did that. We can go ahead and double check it. If I click on it, delayed start is above 1.000 meters. Automatic stop is 1.800 meters. Great. Fantastic. So now I don't have to worry about start and stop. I just press start on the screen. And then at my leisure, whenever I'm ready to go, I just let it go. And as the cart goes through its motion, as soon as it hits the starting line, which is 100, then it will start measuring. And it will stop measuring before the weight hits the floor. Fabulous. So now that we've calibrated when it's recording, we have to go ahead and display the appropriate graphs, as it says in our screen here. Double-click on the graph icon in the display section of the program and select force as the variable and press OK. Okay, so down here, graph, I'm going to go ahead and I can close this guy out, I believe. Double-click graph, okay, and it'll say, hey, what do you want to do? I want to add force. It says that's the first one. Force is great. And let's see here, and press OK. I'm pressing OK. Wonderful. And maximize the resulting graph using its maximize button. I think that looks like this guy in the middle. That's the maximize button. So now I have force versus time, which is lovely. By default, you just created a graph which has force values on the y-axis. That's true, just double checking. And time on the x-axis. That's correct. In order to examine the data using the same x-axis, we will configure the graph to plot force values as a function of position. So we want to not do force versus time, which is lovely. We want to do force versus position, okay? Force versus x. So click and drag the position. Let me read this first, then I'll go ahead and do it. Click and drag on the position entry on the data window and hover the cursor over the x-axis and then drop it down. So this is how we're going to do that. We're going to change this time axis to position. So I'm going to click and drag position and bring it down here, and I'm going to go ahead and hover it over the time. You'll notice it now has a dash thing around it, and let it go. And now we've changed it. So now it's force versus position, which is nice. That's fantastic. Create a second graph by clicking and dragging velocity, okay? And drop it somewhere that's not important, some white space. Don't drop it on the force axis, don't drop it on the legend, don't drop it on position, just drop it somewhere, okay? So we're gonna grab velocity and we're gonna drop it somewhere, like right there, okay? Now we have force versus position, and now we have velocity versus time. There's two of them, great. Wonderful. Using the same method, change the x-axis to position. So we want both of these guys to be positioned. So we grab position, doing that, and we come down to time, and we let it fly, and now they're both, yeah, they are. Did I do that right? I didn't do that right. Darn it. Notice it didn't work. What it did was it added another position. I wonder if I Control Z this because it's Windows. I can't. Can I edit undo? I can't. Darn it. Can I delete this one?